Hey guys, Mr. Hayes here. We're going to talk through and review very quickly rational equations and extraneous solutions. I'm going to go through 5 steps real quick and remind you what those are, and then from there we will do a couple of examples, and then hopefully you'll be in good shape. First step, remember, is you need to always write down the domain. The domain on a problem will be those points or those values of x that will cause the denominators to equal 0. Because, of course, remember, when the denominators equal 0, then we have a situation where you can't obviously, I mean, it goes off to an infinite solution. So we'll do that first. The second set is, remember, multiply all the terms in the equation by the lowest common denominator. What will end up happening then is that the stuff that's currently in the denominator will divide out. And then from there, whatever's left over will give us a nice equation. You're going to resolve that polynomial equation that's left over. It might be linear, might be quadratic, and then you need to discard any extraneous solutions. And when you do that, remember, you're going to compare whatever solutions you come up with in this step here to the domain. So you're going to compare it up to the domain, and then after that, you're going to write down your solution set. So in terms of how to do that, let's take a look at an example. So here we've got, first thing you want to do is you're going to want to factor this part down here. Because these are binomials, they're already factored. Here we're going to factor this out to become x minus 2 and x plus 1. So this is close. This right here presents an interesting problem, the 2 minus x. This is almost kind of like a palindrome of the x minus 2. And so one thing that you would like to do here is I'm going to change this to become a negative 1 times x minus 2. And then, in fact, the negative 1 we can move up into the numerator, so then we don't have to worry about it quite so much. So, in fact, let's do that now. Sorry. So this is going to become, this is going to go up here, which is perfectly valid. So just to rewrite before we start get going, we're going to go 5 over x plus 1 minus a negative, x being the opposite of x, over x minus 2, and that's going to equal 8x minus 7 all over the quantity of x minus 2 times the quantity of x plus 1. Now your common denominator here is going to end up being x minus 2 times x plus 1. So when we multiply this through, again, as I said in the previous step, oh, I'm sorry, before we do that, domain issues. Our domain problem will arrive at x cannot equal a negative 1 here, because negative 1 plus 1 is going to be 0. And it also can't equal 2, because here that would force that to become down as well. So we'll come back to that when we find our solutions. Now, as I said, we're going to multiply everything through here by the common denominator of x minus 2 and x plus 1. When you do that, what will end up happening is the x plus 1s here will divide out. Okay, the x minus 2s will divide out here. Everything will divide out here. So what's going to end up happening is you are essentially then left with multiplying the numerator by whatever does not get divided out. So here, this denominator does not have an x minus 2. So we're going to multiply that through by x minus 2. Here, this is actually, remember, plus. So we'll just write it as plus x times x plus 1, because that's what's missing from down here. And over here on the right-hand side, the denominator isn't missing anything, so if we multiplied it through by the common denominator, that would all divide out. So now we have a very simple quote-unquote quadratic to solve. So we're just going to simplify and move everything onto one side. So I come up with 5x minus 10 plus x squared plus 1x is equal to 8x minus 7. And then we're going to move everything over to the other side. So the 8x comes over here. So I have an x squared out here in front. There's a total of 6x. Minus 8x will be minus 2x. And then negative 10 plus 7 is going to be a negative 3. So I'm going to come up with an x minus 3 and an x plus 1 equals 0. So my two solutions then will end up being, the potential solutions are going to be x could equal negative 1, or x could equal 3. We're going to compare these up to the domain. The domain says we can't have it equal to -1. So this is no longer a viable solution. That's extraneous. And so then your final solution set is going to become just 3. To be thorough, we're going to go through a story problem quick. Inlet pipe fills Sven's pool in 5 hours. So draw a quick little pool. Make it 3. Ooh, that's bad. We won't make it 3-dimensional. Inlet pipe. So that's going to be going in, and that's filling it in 5 hours. Outlet drain pipe. Can drain it in 8 hours. As he used to watch YouTube videos, Sven lists both pipes open. How long did it take to fill the pool? Now remember, we've talked in class about how we go. One of the ways we can figure this out is we're essentially going to figure out what percentage of the job each pipe does. So in this case, together over alone. So the rate together over the rate alone plus the rate together over the other alone. And again, you can do this as many times as you need to. Here we only need to do it twice. So this is going to be the percentage of the inlet pipe. It's going to be the percentage of the outlet pipe. This is all 100%. So in this case, we don't know how long they're working together, so those are going to be x. We don't know, well, we do know how long. It takes 5 hours to fill it, but it also takes 8 hours to drain it. Now, since it's draining it, we're going to make it a -8, and that's going to equal 1. So now, again, according to our rules, we're going to multiply everything through by the common denominator. Common denominator here is going to be 40, because the negative can just slide up here. So when I multiply everything through here by 40, the 5s are going to divide out, so you're going to come up with 8. Here, I'm going to divide out 8 and come up with 5, and this is going to become 40 over here. So this is now going to become 8x plus 5x, minus 5x, because of the negative down there, is equal to 40. So 3x is going to equal 40, and x is going to equal 40 thirds, which is going to be 13 1/3 hours. So that is going to be how long it's going to take to fill up the pool with the outlet pipe being filled up. So those are a couple of examples. Obviously, you can also check your book or talk to me in class. Thanks. Hope you guys have a good weekend.